Okay, so we've got ourselves a formula. Total cost is fixed cost plus repeated cost, and this goes for not just cars, but anything. We'll look later at many other applications of this. So we're just going to do some problems dealing with that formula right now. Find C, which is the total cost, if the fixed cost is $5,000 and the repeated cost is also $5,000. Okay, so for number 4, we don't know what C is, but we do know that the fixed cost is $5,000, and so is the repeated cost. So all we got to do is add those two things together, and I believe we're going to get 10 grand. The idea of formulas is they're going to have variables in them. You're going to be able to establish a couple of them, and from those, you can figure out what the last one has to be. Okay, let's do another one. My bad, I should have looked ahead. So it's number 5 says, assuming the last problem is describing the same car, which is the $250 a month, about how many months have we owned it? So we know we have a $10,000 total cost, of which the repeated cost was $5,000. Now remember, we're not going to look at the fixed cost, because that tells us nothing about how long we've owned it. The repeated cost does. So we've got $5,000 in gas bills, and we know that we pay $250 per month. So what's fun about this is actually a throwback. If you know the repeated cost is $5,000, and you know that the car costs you $250 a month, this becomes a dimensional analysis problem. 1 month costs $250. And what's so cool about that is you now see the units cancel off, and the unit that you want is right there. So all you have to do is, well, do the math, right? So it's 5,000 divided by 250. And if I do the math in my head, that's going to be 20 months. 20 months you've owned the car, assuming that the total cost was $10,000, which means the repeated cost was the $5,000. Cool. I told you, dimensional analysis isn't going anywhere. All right, let's do some more. Okay, different car. We're still going to find... Oh, no, we're not. We know the total cost is $12,000. Check that out. That's the total cost of the car. The repeated cost is $4,500. We're looking for F, which means we're trying to figure out how much the car actually costed. So we know that whatever the car costed plus $4,500 has to equal $12,000. So depending on what math you've had before, you might do this different ways. If any of you have had algebra before, you'd probably subtract the $4,500 from the $12,000 to figure out what the result would be. And that's totally fine. Some of you can probably do it in your head too. You might say something like, well, if it was $5,000, this would be $7,000. And if it were $4,000, this would be $8,000. So that means this has to be right in the middle of those two, which would be $7,500. And honestly, mostly, I just want you to be able to read this and understand what you were looking for, which is actually the answer to number 7. You figured out what the car costs, which is the whole point of this formula. Fixed cost, one-time purchase cost. Repeated cost, total amount of gas you've paid for over the time you've owned the car. And that's the absolute total cost of those two things put together. Okay, let's do some more. Okay, so number 8, 9, and 10 are kind of hinting at what we were doing previously, which is the first car going out year, 1 year, 2 years, 3 years, 4 years, and 5 years. Okay, so we're going to do the same exact thing, except I've erased the formula now, which is totally fine. We can do this. So for number 8, we're going to own the car for 3 years. Number 9, we're going to own it for 4. And number 10, we're going to own it for 5. And I think we should approach this the way we did in the last video. So at number 8, total cost is going to be the fixed cost, which is $5,000. Plus, rather than, since it's 3 years, that's 36 months. Rather than add up $250 36 times, I think what we should do is we should do 36 times $250. And you know what we're gonna do? Just to make this more efficient, I'm gonna do number 9 the same way and number 10 the same way. And then we'll go back and actually get the numbers for them. So the cost here is gonna be $5,000 plus 48 times 250. And then the cost here is gonna be 5,000 plus 60 times 250. And let's just make sure we understand where I'm getting these numbers from. Since a year has 12 months, and since the cost of the car is being given in dollars per month, if I multiply this by months, we're right back to our dimensional analysis fun. And we're left with just dollars. I'm leaving some of those units off, but that doesn't mean the units aren't there. They're just working in the background. Another way to look at this is you could figure out how much gas cost is per year and then multiply by years. But since we're sticking with months right now, I thought I'd stay with that. So all we got to do now is, like we said before, do the math. So we know that if it's $36 times 250, let me see, I'm going to have to do this slow. That means it's 1,000 times 3 times 3. So that's going to be 9,000 extra dollars. Plus the 5,000 here. That's going to be $14,000. Man, cars are expensive. I'm not really sure if I kind of did this right as far as estimating the purchase price and the gas cost, but even if I did it wrong and underestimated, that's still pricey. Another year, 12 more months, and that's going to give us $17,000. And then another year and 3,000 more bucks, that's going to be 20 grand. There you go, 20,000. So it's $14,000 for 3 years, 17,000 for 4, and 20,000 for 5. And that's the basic idea of how to kind of crunch out these formulas. We're going to go further. We're going to use Google Sheets to do the heavy lifting for us because, you know, mental math is great when the numbers are nice like this, but when the numbers become not so nice, that's when spreadsheets really, really come in handy. So let's take a look.